Here's another thing about the acceleration. Again, you have a lot of intuition on acceleration. I just want to keep using this. The direction of the acceleration can be determined by your body's motion. The direction of the acceleration is always opposite of your body's motion. Well, let me see if I can write that down. So the direction of acceleration is determined by your body's motion. So your body is telling you the direction of the acceleration. So the acceleration direction is always opposite of your body's motion. Okay? So let's look at this thing. So again, you have to think about your body. Now, if you're driving at constant velocity, so imagine that you're on the highway and you're driving, let's say, 65 miles an hour because you're an upstanding citizen. What happens to your body? Does your body move forward? Does your body move backwards? The answer is no, it's stationary. So if you're driving at constant velocity, and I could imagine that I have a car okay? And what I'm going to do here is that I think I'm going to copy this car just to be faster. So here's the car. And all we know is that this car is moving at a constant velocity. Okay? And of course, it's on blacktop. So I'm going to copy this so that I can use this. So if you're driving at constant velocity, what we say here is that your body does not feel anything. It's not being pushed at all. So what we say here is that because it's not being pushed, we say that the acceleration is 0. So guess what? I'm going to come in here and I'm going to say acceleration is 0. Your body doesn't feel anything. Now, let's go put in the cars. Now we're going to do exactly what we talked about before. We talked about speeding up or slowing down, speeding up, and then we're talking about turning. So let's look at these 3 situations. So in this situation, I'm going to talk about braking. Speeding up. Turning. And remember, these 3 cases are the case that we just did, right? A hard braking, speeding up, turning. That's why I have these cases. So then I'm going to feel my body. So in each situation, you see that the car has a velocity to the right. Now, if I brake, which direction does my body go? So if I brake, I know that this direction, my body moves forward. So if my body moves forward, the acceleration must be opposite of the velocity. It's opposite of the body's direction. Now, if I'm speeding up, we feel that our body goes in which direction? It's like being pushed into the chair. So our body goes in that direction right there. Therefore, the acceleration must be what? In the opposite direction. And when I'm turning, it feels like my body goes into the door. So this is hard to draw here. So what we're going to say here is that your body is sort of like going into the door. So what happens to the acceleration? It turns out it's got to be perpendicular to that. So then the acceleration is perpendicular to the velocity. So in summary, this is what we could say. If you're moving at constant velocity, what happens? Constant velocity says my velocity vector looks like this. My acceleration is 0 because my body doesn't feel any force acting on it. But then what happens? If I'm speeding up, I then see that the velocity and the acceleration are in opposite directions. Ooh, boy, did I say that wrong, didn't I? I meant to say slowing down. So let me write slowing down. And then if I'm speeding up, then I see that the velocity and the acceleration are pointed in the same direction. And if I'm turning, it turns out that I can do two things here. So it turns out that if I go in this direction, and the acceleration in this case is perpendicular and to the right, this guy is going to be what? This is going to be a right turn. On the other hand, if I have it the opposite direction, where the velocity goes like this and the acceleration goes up, this guy is a left turn. So when you look at this thing, you could see, what do I mean by acceleration? When I look at acceleration, if I'm slowing down, speeding up or turning, it's the direction of acceleration. So a lot of the times, this is what we say. We say that when we say the word deceleration, this is really what we call negative acceleration. It works against the velocity. In everyday language, when we say we are accelerating, we call this positive acceleration. But you could see that it's really just the arrow that's happening here. And here, when we call this turning acceleration, what you're seeing here is that this is perpendicular acceleration. So anytime the acceleration is perpendicular, you will be changing directions. Anytime the acceleration is either against or with the velocity vector, you will be slowing down or speeding up. And anytime when you have zero acceleration, you do not change your velocity at all. So when I look at this thing here, I'm now going to change the motion diagrams. Okay, let's look at the motion diagrams. So now, motion diagrams. with acceleration added. So what happens when we do that? Well, it comes down to this here. One, we have to start off with constant velocity. Constant velocity, what do we know? We know that the dots have to be what? They have to be equally spaced. So if I'm looking at my arrows are looking like this. Since the arrows do not change, we then say that the acceleration is 0. Again, what does that mean? Arrows do not change. So a shortcut to writing this is to write that we're having a velocity in that direction, an acceleration of 0. Now let's talk about changing velocity. So if I look at my motion diagrams now, I'm going to talk about changing velocity. And we know that there's 3 ways to do it: speeding up, slowing down, turning. Okay, let's draw them up. So if I know that I'm speeding up, we know that the dots have to be getting farther apart. Like this. So that means then when I look at my arrows, they're getting larger and larger. Now the reason why they're getting larger is because the acceleration is what? Helping the acceleration, helping the velocity. So then when I draw my shorthand, I can draw this instead and say, yep, that means speeding up. And if I talk about turning, no, not turning, slowing down, then of course we have the opposite situation. So in this case here, we're seeing that the velocity is getting smaller. So if I look at this thing, they're getting tinier. In this scenario here, we say that the acceleration is working against the velocity. So then I can redraw this and draw it like this. And then the third case is turning. Now, turning acceleration, what we're doing here is that we have to keep equally spaced dots for uniform acceleration changes. So when I look at the velocity, it's doing something like this. I'm trying to draw all these velocity vectors the same length. So when I look at this thing, look at the acceleration, it has to be perpendicular. Look at the acceleration, it has to be perpendicular. I have to draw all of these perpendicular here. And what you're seeing here is that look at these arrows. These arrows are all pointing towards the center. And so what you're seeing here is that the definition of centripetal acceleration is that it's center seeking. If it's center seeking, that's what centripetal actually means. So centripetal acceleration is center seeking, and then I can abbreviate this by drawing this thing. The velocity goes this way, and so the acceleration is perpendicular to that. And that's what gives you a right turn.